All right, number 4 is talking about there's a car. It's traveling down a long, steep hill. The elevation E above sea level in feet of the car when it is d miles from the top of the hill is given by E equals 7,500 minus 250d, where d can be any number from 0 to 6. So, I mean, I like to, with something like this, to try to remember the first step in understanding in problem solving is to understand the problem. So we've got this car. The car is E miles above sea level, right? At the top of the hill. And then anytime it travels d miles, so here's the car now, right? And anytime it travels a certain number of miles, that's d miles, right? And so apparently it's obviously takes 6 miles to get to the bottom of the hill. That's why d can be from 0 to 6. So remember, the d is not, the e is straight up and down measurement, but the d is more about how long the car has to travel along here, which is not a straight up and down measurement. So they're not exactly equal. And you can see that the elevation is dropping by, so when you're looking at this, this is the equation for what's happening, and that equation has meaning. These numbers in the equation have meaning. When it asks what is the slope of the function, the slope is the number being multiplied by the variable. So this is in slope-intercept form, right? Kind of like y equals mx plus b. The number being multiplied by the x is your slope. So that's negative 250. But what does it mean in the context of the moving car? This means that this is like negative 250 over 1. And I have to admit, I'm going to jump down. One of the things that helps in trying to calculate a meaning, so rise over run is a slope, is matching up independent and dependent variables with these numbers. So the independent variable here is d miles from the top of the hill, right? And dependent is E elevation above sea level. So remember that rise is up and down, so that's going to match with your dependent, up and down. So we're talking negative 250 feet above sea level. That's what's going on here. And down here we're talking about 1 mile from the top of the hill. So this is why identifying independent and dependent variables can really help with interpretation, because your slope is really a rate of change. And if you can match those numbers to the independent and dependent variables, it becomes pretty easy to interpret it. So now I just need to say this in a sentence. It's a good idea to start that with a for every. For every 1 mile that you go down from the top of the hill, or for every 1 mile you travel away from the top of the hill, you decrease your elevation above sea level by 250 feet. So that's a sentence that you should write out, or you should say in your own words. What is the y-intercept of the function? That's the b value, the number that's not with the variable. So 7,500, and what does it mean? So that's your starting place. So remember, this is about elevation. Again, your y-intercept is related to your dependent variable. It's basically the number that you get when your independent variable is 0. So when d is 0, when the distance from the top of the hill is 0, so in other words, when I'm at the top of the hill, when I'm starting out, my elevation is 7,500 feet. So when I'm at the top of the hill, this is basically kind of an when d equals 0, E equals 7,500. So that's the math way of saying it. And here's the English way of saying it. When d equals 0 means when I'm at the top of the hill, E equals 7,500, then that means my elevation above sea level is 7,500 feet. So that is how to kind of break down a meaning of y-intercept, again, knowing what your independent and dependent variables mean. What's the domain of this function? Domain is what are all the values your independent variable is allowed to be. So again, knowing what your independent and dependent is about is helpful. D miles from the top of the hill. What can my D be? And it actually tells me in this problem. D can be any number from 0 to 6. 0 to 6, that's the domain. And if you want to be really mathematically sound in writing this, you can write it as an inequality, where D could be bigger than or equal to 0, but it has to be less than or equal to 6. So what's the range of this function? Well, the range of this function is dependent on the domain, right? We know that the elevation can be as high as 7,500. So we know that 7,500 will be the greatest value. But what's that elevation when you get down here? So when you get down to 6 miles, we need to figure that out too. 7,500 minus 250 times 6. That equals 7,500 minus 1,500, which equals 6,000. So what's happening here is I'm going to start at the top of the hill. I'm going to be at 7,500. And then as I go down 6 miles, I'm going to end up 6,000 feet above sea level. And that's as low as I can get. So my range is between 6,000 and 7,500. Again, you can write this not that way. 6,000 is less than or equal to E is less than or equal to 7,500.